So when you go to Cranium Cafe, you scroll down to Library and Learning Services, and you'll see my name and I have my hours, and then you just, it will show like it shows the other people, knock on the door. So you just knock on my door and I can invite you.
I was so excited it worked when I found it. Once I found it, it was so easy to interact or to access it, whatever you want to call it. And the greatest thing that's going to come out for me with school of this pandemic is I'm going to know how to operate all of LTCC stuff the quarter I leave.
Okay, should we get to the quiz?
Yes.
Okay, let's take a look. So I'm going to share my screen. And let's take a look at the quiz. Can we do it? Okay, so here's the quiz. And let's see that. There we go. Okay, so the question was, a survey was done, okay, of 200 ski pass holders at Sierra at Tahoe, asking them if they, oh, you know what, sorry about that. It should say they ski, snowboard, or both. Okay, they were also asked their gender. The results of the survey are shown in the table below. We got ski, board, both, male, female. Okay. So notice, I don't know if you remember, what do you call this kind of table? Any remembers? Don't see y'all jumping in. If you don't remember, it's called a contingency table. Okay, so it's a table of counts when you have two survey questions and you're counting in how many of these things happened. So part A is if a randomly selected a pass holder is selected, what is the probability that the person is a male who both skis and snowboards? Okay, so what we have to do is we say, well, the person has to be a male who both skis and snowboards, and notice from the table, there are 30 of them. Any questions on that? Okay, this is not a given question. We're just grabbing a season pass holder. We're not told anything about this person. So that means the denominator is going to be the entire sample, and that was 200. So the answer to this one, so this is male and both. Write down P of male and both will be equal to, and again, it was 30 for the numerator and 200 for the denominator. Okay, unlike your homework, you don't need to do any like turn into a decimal and round and all that kind of stuff. This is fine to leave it like that. Any questions on part A? Okay, it's always easy to watch, isn't it? Okay, now B is if a season pass holder only snowboards, what's the probability the person is female? So now we go. And now this is different than part A in that we're told something about this season pass holder. We're told that the person snowboards. Now the probability that we want to find is female. So let me write that in symbols first. So that's the probability of, I'll just use F for female. And then that's a given question because we're given that the female is a snowboarder only. I'll just write SN for snowboarder. Any questions on the symbols?
I hate the symbols, but I get the problem.
The symbols help a lot because that's going to help us understand what to do, especially in the next one.
They confuse me so much, and I'm trying to find ways to not be confused by them, but when I use the symbols, I don't get the problem right. When I just translate
them right, you should.
I know. When I translate just the numbers, I get them right.
I mean, if you get them right, that's good, but most people have a lot of trouble if they don't use a symbol. That's what I've learned just from my teaching.
I'm never in the 99.9. I'm in the 0.001.
And that could be. So the key on this one is that if we're given that they're a snowboarder, so that means that we're only talking about this group of 46 and this group of 37. That's our new population. So that population is a total of 46 plus 37, which is 83. Okay. And then we want to find out that they're a female. Okay. So the females are the 37. So it'll be 37 out of 83. And that's it. Any questions on part B? Maybe I'll label them as A, B, and let's go to C. Are being male and only snowboarding mutually exclusive? And I want to mention, explain numerically, you lose points if you don't. Okay, that's necessary. So there's a definition of mutually exclusive. Who remembers the definition, the numerical definition of mutually exclusive? That's the P. Can you remember? It's zero, but something's zero. It's a probability of A and B. Or in this case, because we're looking at male and only snowboarding, that'll be the probability of at male and snowboard. And the question is that equal to zero? Well, let's calculate that probability. So if you go to the male and snowboarding, there's 46 of them out of 200. Any questions on that? That's 46 out of 200, which is not zero. So being a male and only snowboarding are not mutually exclusive. Any questions on part C? Okay, let's go to part D. Okay, part D was, are being female and only skiing independent? Explain numerically. So there's three choices on this. I would say two are easier, one is harder. So I'm going to pick one of the easier ones. There were three formulas. So we got, again, it's female and only skiing. So what we want to do is want to say is the probability of female given skiing, is that equal, and I'll write equal to with a question mark, to the probability of female. Any questions on this example so far? I mean, this decision on the equation. There were two other choices. I think this might be the easiest of the three, though. So now we just check. So probability of female given skiing. Well, the probability of female given skiing, we look at the skiers. There were 25 and 29 skiers. That's 40, 54. 29 of them were female, so 29 over 54. So is 29 over 54. And is that equal to the probability of being female? And female, let's count them out. 29 plus 37 is 66. Plus 33 is 99. And that's out of 200 total. There's no given here. So is that equal to 99 over 200? Are those equal?
No.
Yeah, they're not. And in fact, I think I did this ahead of time. 29 over 54 is 0.5370. Let me write equal question mark. 0.5370. And is that equal to 99 over 200? Was it 99 over 200? I think so, right? Yeah, 99 over 200. And 99 over 200 is what is it, 495, if I did it in my head right. And they're not equal. So since they are not equal, we can say that being female and skiing only are dependent. Any questions about question 1? Any questions? Okay, let's go to question 2. Okay, and by the way, I make this up. So actually, when I said a survey was done, I doubt a survey was really done. So don't quote me on it, please.
I'd like to see the documents.
Huh?
I'd like to see the documents.
Yeah, there's no documents. I'll tell you when you can quote me. If I ever give a reference, then you can trust that it's real. If I don't give a reference, then it's just, I made it up. And that includes the homework assignments, by the way, too. Just a note is whenever numbers are given in the homework, if a reference is not given, then there's made up numbers. And usually in the homework, they're randomized numbers. Okay, if there is a reference, then you can trust it. Okay, or at least you can trust if that reference is good. Okay, so suppose, and if I ever say suppose, that really means I made it up. 12% of Americans are left-handed. I think it's very helpful to turn all these into symbols. So left-handed, let's call it L left-handed. So the probability of L is equal to 0.12. 30% play musical instrument. Let's call M for musical instrument. Probability of M is equal to 0.3. And if you want 30, but I'm going to keep it as 0.3. Prettier. 15% of those who play a musical instrument are left-handed. What is that the probability of? See if you can put in the chat box. What's that the probability of? That 15% or 0.15. What is that the probability of in symbols? That's usually the hardest part of these kind of problems. Yeah, so that's going to be probability of L given M, because we're told that they play a musical instrument and then 15% of them are left-handed. So that's the probability of L given M is equal to 0.15. Any questions on the givens? Now we can answer the question if you can read the questions as symbols. So if an American is selected at random, find the probability the person is left-handed and plays a musical instrument. What's the key word here that's going to help us here? It's a small word, 3 letters, that's a hint. When you read through that sentence, there's one important word that's 3 letters long. Any ideas on part A? Yeah, and. There's an and question, okay? Because on part A, it has that word and, okay? It's not hidden or anything. There it is. Of course, now it's all highlighted. So that is going to be the probability the person is left-handed. That's the probability of L and musical instrument, M. Well, there's a formula for that. That's the probability of L given M, because that's the one we know, times the probability of M. And that's just 0.15 times 0.3. And that is 0.045. Any questions on that? Okay, let's go to B. So part B is if a left-handed American is selected at random, find the probability that the person plays a musical instrument. So in symbols, what is that? P of, see if we can put in the chat box. Yeah, that's M given L because we're told the person's left-handed. Now we want to find the probability that they are a musical instrument player. It's going to be probability of M given L. And there's a formula for that. That's the probability. It's the same formula as above, kind of. Okay, that's the probability of M and L divided by the probability of L. And probability of M and L, that was 0.045 divided by the probability of L. The probability of L was 0.12. Any questions on that? If you want to do the arithmetic, you can. On quizzes, I'm okay if you leave it like that, though. Okay, so that's the whole quiz. Any questions at all on the quiz? Any questions? Okay, I want to let you know something, and we'll talk a little bit more about it as we go in today's lecture. That is, the quiz Thursday has a very extra important special element that might freak you out, but I'd rather you freak out on Thursday's quiz than on the big exam.
Me too.
So I want to ease you into it. Thursday's quiz is going to use Proctorio.
Oh, God.
Huh?
Oh, God.
Has anyone used Proctorio before? Okay, so don't say, oh God, until you know what it is.
It's just added pressure. Proctorio is knowing there's some stranger monitoring what you're doing. So
Actually, it won't be a stranger. It's going to be me.
Oh, okay. So even worse, someone that we respect and value is staring at us.
Yeah, and actually it's a video and I can watch the video is the idea.
What was our behavior during that quiz? Did we look stupid? Did we embarrass ourselves?
I'm not that's not a problem. You don't have to feel bad about that. Now, if there's someone behind you whispering in your ear the whole time, that you should worry about. Because yeah, that's not okay. So just let you know, the rules of Proctorio for me are you're not allowed to talk to an adult. So
But
if you have a 6-year-old child that says, or maybe a 3-year-old child, I got to use the bathroom, then you could talk to your child. Okay. If you have a 16-year-old child, tell your 16-year-old child don't talk to you for 2 hours. Does that make sense?
2
I
hours.
call that. I'm going to go adult being post-pubescent. We'll make that definition of adult, not the 18 adult.
Okay.
So, post-possession kids, they don't want to be around mom and dad anyway. So just to know. So that's going to be a rule. And again, it's good to get used to the rule now, or not now, but in 2 days, so that when you take the exam, there isn't going to be a big problem because you're going to be used to it. Austin asked, can you use a phone as a calculator? And the absolutely answer is no. But I'm going to show you what's better. I woke up at 3 in the morning this morning, and I put some extra stuff together. I've been working on this for months, not knowing that we were going to be doing this. I just like to do this stuff. And there will be a calculator embedded in the problems. Okay, so there'll be an embedded calculator. I'll show you what it looks like in a little bit when we get to the problems. And it's basically the calculator from the textbook. Okay, so that's just a note, so you'll know you can practice it. Okay, and again, this is the first for me. Okay, actually for you guys it'll be the second for me because tomorrow I'm giving it for my calculus class. but basically it's the first week ever using Proctorio. I hope this works. You must have a computer with a camera on it. If you don't, then the college has them. You just have to go and make an appointment. If you let me know, then I can give them the affirmation that you need one. And then you can make an appointment. They could probably do it tomorrow if you made the appointment. And they'll give you one, not forever. You got to turn it in June, but they will give you one. So that is not a problem. It shouldn't be a problem, the Chromebook. The other thing is you must, if you have your own computer, then you must have Chrome on your computer. Got it? So if you don't have Chrome on your computer, it's a free download because Proctorio only works with the Chrome browser. And again, I didn't program Proctorio, so if you don't like it, sorry. But it's all our college has. It's the only thing I can do. So you're gonna have to have a computer with a Chrome browser with a webcam. And you just put everything like your smartphone and all that, just keep it away from you so that, you know, it's not seen or not near you, which is what you should do on a test anyway. You shouldn't be distracted. And other people aren't supposed to be around you. Again, if you have a child, that's different, a small child. That's totally understandable. Unlike this video, it's not posted on YouTube. I'm the only one that sees it, okay? Just to note. You're gonna, and I'll show you the calculator in a bit, but there'll be a calculator embedded in. I'll show you kind of how that looks. Any questions about Proctorio?
Will we have a link like we do for these webinars and the Zoom meetings? Will we have a link on the page, or do we get Proctorio in advance?
Supposedly, again, I've never used this before, but what's supposed to happen is you open up your quiz and your webcam will pop on up and turn on, and that'll happen. You don't have to do anything.
Oh, great.
Yeah, so that it's automatically embedded in Canvas. That's the main reason why everyone uses Proctorio in California. Okay, any questions on this? Okay, just wanted to make sure everyone knows what's going on. Okay, any more questions about the quiz or the coming up quiz? Just want to make sure you know what's happening. Okay, and by the way, with the Proctorio, you're only allowed to look at the quiz. Okay, you can't have other tabs open on your computer. You can only have your quiz tab open. But in that quiz tab will be the calculator. Okay, so just to let you know. Okay, so let's go to new stuff. So that is, let's scroll. Okay, I've talked about the project a little bit already. Are there any questions before we move on about the project? Okay, by the way, don't be afraid that we're doing a whole chapter a day this week. This is nothing like chapter 3. Okay, this is so much easier than chapter 3. Doesn't mean that like you don't have to do any work, but this is not what everyone complains about. So that's the good news. So we're doing a whole chapter. It's a small chapter. And in fact, the original book that we used, I got rid of sections and you don't even see them in the book now because I just destroyed them. And we don't do those sections and they're just gone. That's just a note. What we are going to do is discrete distributions. Who remembers what a quantitative variable is?
It can be counted.
Not quite. That turns out to be what a discrete variable is.
Of course.
Be measured, but in particular, what is the answer to the survey question? If it's quantitative, it's a number. And that's the most important thing. A quantitative variable means that the answer to the survey question, or you can think of as the data that you write down in your spreadsheet, is a bunch of numbers. Is that clear? It's not yes, no. It's not California or, I don't know, some person's name or something like that. It's a number. Okay, it turns out there are two main types of quantitative variables that we're going to be working on in this class. And to let you know, today, we're going to be dealing with what's called discrete variables. And on Thursday, we deal with the other kind, okay? Continuous variables. But today is going to be discrete variables, and that's a special kind of quantitative variable. So this isn't quite a definition, but it basically is. So a discrete variable is a quantitative variable where all the outcomes can be listed, possibly with, let's write ... notation. Okay, so that's a quantitative variable that's discrete. So let me give you some examples. So one example might be something like, how many hats do you own? So you can put in the chat box, how many hats do you own? Okay, and if you don't know exactly, just make your best guess. Well, I own a lot more hats than any of you all, but I hike a lot. Okay, so notice we can list all the possible hats that can be owned. Okay, so the answers, you can own 0, that could happen. Okay, most people don't own 0 hats, but it could happen. You can own 1, you can own 2, you can own 3, you can own 4, you can own 100 hats. Okay, but if I write ... I kind of listed them all. Does that make sense? How many do I own? I'd have to count. I'd say around 20-ish. Yeah, but I kayak, I bike, I hike, I do all kinds of outdoor stuff, and they all need different hats. And they get sweaty, and then you got to get a different one and throw it in the wash. I don't like smelly hats. Okay, or other people don't when I'm wearing them. Okay, so that's an example of a quantitative survey question. I mean, a discrete variable. Okay, here's another one that's interesting. So notice, by the way, what do you notice about all these numbers? Yeah, they're all whole numbers. Now let's try another one, including yourself. How many siblings are in your family? Okay, and again, the rule is if you don't want to tell anyone, you can make something up, that's okay, but most people are okay. I'm trying not to do personal stuff. Well, we got a 12. That's pretty impressive. Okay, so notice, this is the first time I think I've ever taught this class where somebody was like me. And that is we have someone with 1.5 siblings in their family. By the way, my family, any guess?
3.5.
Really close, 4.5. 4.5. So there's 4.5 in my family. So you can have half a sibling, that can happen, but you can't have, say, a third of a sibling. Just makes no sense. So you can actually list them. What's that?
Unless you're on a talk show.
I'm not going there. You can't have, biologically, you can't have a third of a sibling, period. You can have halves, but you can't have anything other than halves and wholes. So notice that those are countable. I want to mention something. This is some grammar. I know, this is the math class, but it turns out that it helps to know grammar. I actually learned this when I taught English, believe it or not. I taught English as a foreign language in Japan. And the words how many, almost all discrete variables, the question can be a how many question. It's not 100% perfect, but just about all. Okay? If it's not discrete, but it's also quantitative, it wouldn't be how many. What would it be? How would you start if it's not discrete instead of a how many? Anyone taught English like I did? Especially as a foreign language? Anyone know what you would say if it's not discrete? You all know it, you just aren't thinking about it. So think about something not discrete. So an example of something not discrete might be your weight. Okay. And you don't say how many do you weigh? That wouldn't make any sense, does it? How would you say it?
How much?
How much? Okay. So if it's the opposite of discrete, the grammar is most of the time how much. Okay. How much do you weigh? How much time did you spend in the shower the last time you showered? Okay. Not how many time. Does that make sense? So if you can do a how many, it's almost always going to be discrete. Whereas if you have to do a how much, it's almost always going to be non-discrete, which is what we're going to call continuous. Any questions on the difference between discrete and continuous? Okay, the thing about discrete variables, since you can list them, and often you can list all possibilities without ... Okay, even if you go a while, you know, how many siblings in your family? I would say after you got to the number 200, you're done. No one's going to have more than 200 siblings. That'd be weird. Okay, call it 400 if you count the halves. Okay, so in particular, you can list them all. So I want to do an example. And now they're going to be a word problem-y example. Okay, so here's the example I have. And I want to let you know when I have these examples in your Canvas shell, these are in there. I posted them in the module. So that it's usually at the end of the information mob in that week. So here's what it says. A car salesperson gives out a $10 gift to every customer who test drives a car. You've heard of that before, haven't you? You go, you take a test drive, you go to their shop, I mean, their sales place, and they give you something, okay? And let's assume the car salesperson has to pay for this gift. Let's suppose 12% of the customers who test drive the car, I guess it should be purchase, the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. For the salesperson. Okay. By the way, any of you had a job where this kind of stuff happened? Where you worked on commission? It's a common job, not just car salespeople, but there's a lot of jobs that work on commission. Okay. So some of you? Okay, so it's a typical thing. So we want to write down a probability distribution function for the salesperson's profit. Then find the expected value and standard deviation and interpret the expected value. And then, is this a lucrative job? By the way, something I've learned from teaching this, and I've used this a lot. Do you guys know what the word lucrative means? I found out a lot of people don't.
Yeah.
Okay.
It is a lucrative job.
That's a job where you're making good money. You're happy about the money you're making. That's a lucrative job, basically. Okay. So the question is it a lucrative job? And we're not ready to answer the question yet. Remember, you got to give everybody who comes in $10. You may lose money with this job. Does that make sense? So what we need to do is we need to come up with first what's called the distribution. Notice, is this a discrete distribution? What do you think?
Yes.
Yeah, the outcomes are all numbers, right? And there's only 3 different outcomes, right? Right? Either they sold the regular car, the base model, they sold the luxury car, the deluxe model, or they didn't sell anything. There's only 3 things that could happen. Is that clear? So, and they're all numbers because it's a profit. A profit is a number, right? So it's definitely a discrete distribution. When there's a discrete distribution, we can draw a probability distribution table. And I'm going to go insert table. And we have 3, and I'll put some labels into. Ooh, that was weird. Just a minute. Let's put it down there. One more try. And let's do the following. That way we can see it. Okay, so the first thing we want to do is write down the probability distribution table. In the table, the labels are always X and P of X. So whenever you're drawing a table, those are your labels. X corresponds to the value that occurred, and for a discrete distribution, we're able to list the values. P of X, what do you think P of X is? I hope you all know. What does P stand for? Yeah, P stands for probability. So it's the probability of that X happening. So let's think about the different things that could happen. Well, one thing that could happen is the customer purchased the base model. Okay, if the customer purchased a base model, what is the salesperson's commission? How much money is the profit? So what's the salesperson's profit? Yeah. So the profit is 190. There's a very important formula from economics that hopefully you all know already, and that is profit is equal to revenue minus cost. How much you get minus how much you have to pay. So in this case, we can do that in our head, hopefully. 200 minus 10 is 190. Any questions so far? What is the probability of a $190 profit? The hint is it's given in the paragraph. Yeah, it's 0.12. So notice that you always want to turn into a decimal because we're going to be using a calculator on a computer, and they need a decimal. Okay, but the deluxe model might be sold. What's the profit if the deluxe model is sold? Yeah, that'll be 290. Okay, and that probability is what? Okay, be very careful about that probability. It's not 0.8. Yeah, that's really important. You got to remember the decimal moves over 2 places. You get a 0 there. 0.8 is 80%. So be very, very careful. It's a common mistake. So 0.08. Is that all that could happen? What do you think? Now, what else could happen? Yeah, exactly. If the customer doesn't purchase anything, salesperson is out of luck, and the profit is negative $10. Okay, that happens a lot. How do we come up with the probability that that happens? Yeah, rule of complements. So notice we're going to take 1 minus 0.12 plus 0.08. So 1 minus the sum of the other stuff. And 0.12 plus 0.08 is 0.2. 1 minus 0.2, there's your 0.8. Any questions so far? Okay, so now what we need, okay, so now we got this is called the probability distribution table. And I asked for that, by the way. You're expected to know how to do that. Get ready for that in the quiz, by the way. Okay, next. Now we need to compute the expected value and standard deviation. Let me show you how to do that. First thing is you're going to go to the book. And on the quiz, it'll just be there for you. So let's go to, I'm just going to go to the book the way I know how to find it. Where am I? This guy. Sorry, the Zoom thing is in the way. There we go. We're in statistics. But you could also go from the Canvas page too. Now you probably don't know about all this stuff, and you don't have to, just go for the Canvas page. But I know how to do this. I can go to our book. Getting there. Okay, we're in chapter 4. And we're doing expected value and standard deviation. So in here, is online expected value and standard deviation calculator. So what we have to do is you just put in the table. Okay. And if you remember right, we had X could be 190. X could be 290, I believe, wasn't it? Let me double check. Yep, and -10. The probability of 190 was 0.12. The probability of 290 was 0.08. And the probability of -10 was 0.8. Any questions so far? Okay, so now we just scroll a little bit and just hit calculate. And there it is. So our expected value is 38. Our standard deviation equals 98.47. Why am I carrying 2 decimal places? Why do you think that's a good number of decimal places here? 1 or 3 would be bad, actually. Yeah, this is money. Nobody does 1 decimal place for money or 3 decimal places. So you either do 98.47 and say $98.47, or you do 98 bucks. You could do the nearest dollar if you wanted. That's totally your choice. But it's important to understand kind of where this is all coming from and why, what this is saying. And this is talking about money, and money should be done right. And that's dollars and cents or dollars. Any questions so far? Okay, so let's go ahead and up this one. And let's look at, I'm going to write EV for expected value. And the expected value was 38. And I'm going to actually put a $sign there. And our standard deviation, and this is going to be the first time that we've, actually no, second time I think we've talked about the symbol. Who remembers the symbol we use for standard deviation? The hint is it's Greek. Okay, the symbol is sigma. Okay, can I show you how to use a calculator one more time? Sure. And by the way, on your quiz, there'll be a different way of getting the calculator. You're just going to click on expected value and standard deviation. It'll get you to the calculator. Okay, and you won't be able to do much else other than that. There'll be a bunch of choices, and you're going to have to click on expected value and standard deviation. So sigma is how you read that, is equal to $98.47. Okay, any questions on getting those numbers?
So on the test, we'll have the same table available for us to find out the standard deviation.
Yep. The only thing I did change on it is if you look at the table, the width of the columns is really wide. You notice that? And it doesn't fit very well in your quizzes, so the width is going to be a lot narrower.
Okay, thanks.
Which is it, and I did that because it's just too cumbersome the way it is. It didn't work well. So other than the width, it'll look exactly the same. And it's very easy to type it in, you hit calculate. Okay. And there's a little error on this one I got to fix. I fixed it on the other one. If you calculate twice, it makes a mistake on the standard deviation. Okay, so let's go back. Now we need to interpret the expected value. Okay, so here's how we interpret it. So I'm going to type it out and I'm going to talk about it. So if the salesperson sees many customers then it is very likely that the average profit per customer will be close to $38. So I want to do a few things. First thing is many. Highlight many. Second is likely. And I write very likely just to emphasize it. So if you want to write very likely, that's good too. Another one is average. Okay, and then close to. Okay, so in my class, these words are a requirement when I ask you to interpret the expected value. Okay, so let me ask you, how many of you are going to not put those words on your quiz and then your exam when I ask you to interpret expected value? Let's say you will remember to put those words, or you won't put those words.
I'm going to put those words.
Okay.
All
Guess what
over.
happens if you don't put those words? Guess what will happen?
You're going to lose points.
Yep. And if you do put those words, guess what will happen?
Bonus points.
You will get points, even if you didn't compute the expected value right. I will give you points just for having those words. Got it? Okay, so these words are what it's really all about. And it's also a way of talking about the law of large numbers. That's what the law of large numbers is if you do something many times, then it's going to be likely that the average is going to be close to whatever you expect it to be. So if you flip a coin 1,000,000 times, then it's very likely that the average proportion of heads is going to be close to 0.5. Do y'all agree?
Yes.
Okay, that's all that is. Okay, that's called the law of large numbers. Okay, is this a lucrative job? So let me ask you, and by the way, this is not a math question. How long do you think it takes to show a car to someone?
Couple of hours.
It takes,
The
yeah, you think
whole
it's,
process takes a couple of hours.
okay, so Austin says an hour, you say a couple hours. The funny thing, you guys, you're just showing it, right? You're not doing that. You're the salesperson. You're not the final person in the other room. You know what I mean? I don't know if you know about car sales, but you go to a salesperson and then you go into the office. And that's usually someone else. Okay, so if it takes an hour, do you think that's a good job? What are you making?
$38 an hour.
Is that good?
That's good in
Okay,
some
depends.
areas, but not in every area. It depends on what you consider good. So it's
Exactly.
still subjective.
Exactly. So it's definitely above minimum wage. Okay. Okay, it's definitely above minimum wage. Even, by the way, if you say it took a couple hours, it doesn't take a couple hours to show a car, by the way. I have not done it. My brother was actually a used car salesman when he was in college. He made good money. And it didn't even take an hour. It doesn't take an hour to show a car. It just feels like it might, but it doesn't.
You're right, because I talk total package. To show a car, it doesn't take long, especially if they're not going to test drive.
No. Even if you test drive, that's 15 minutes. Yeah, so it's not that long. So the point is, it's a lucrative job, but let's look at that standard deviation. What does that tell you? Is it big or is it small? Yeah, it's a pretty big standard deviation, especially compared to the expected value. It's more than twice the expected value. Do you see that? Yeah, exactly. It means that don't expect on your first day on the job to make a lot of money. You might, but you also might not. But if you work for a month, then you're going to make a lot of money for sure. Okay? It's very, very likely that the average profit will be close to. You see how that works? So let me tell you how I have used that up here and somewhere else too. This is really important. And what's one of our big economies in Tahoe where expected value is important? That's closed now, as everything else is. I don't think expected value is very important for skiing, actually. Timeshare, a little bit.
Answer.
The casinos.
Oh.
The casinos. It's all about expected value. Okay. So I'll tell you a story. I used to teach a class called Statistics of Gambling. And I had a student, and she was the head corporate manager. And she, at the end, at the break during the class, after I talked about expected value, and she said, well, this doesn't make any sense because in my casino, we're losing money over the last month at our, I think it was one of the tables. Okay, I talked about the odds and stuff like that. Do you know what I told her? No, it turns out that card counting wouldn't work. That's my fault, by the way. I also worked for the casinos and made sure card counting can't win. Okay, no, I told her to look at the videos. The next day, the big article in our local news was that they caught a scheme of dealers that were cheating, dealers and players that were cheating and stealing money from the casinos and making it look like they were just losing. And they caught them, but it was based on this information that I gave her. And it was pretty cool that I actually made that happen. And it was all about expected value because I was convinced her, since we had many customers, this was weeks of playing, that can't happen. Okay, you can't have the tables losing. So if you're a business person, you definitely want to look at your expected value, and if it's positive, then you will make money unless someone is stealing from you. Okay, and then all bets are off, right? Any questions on this idea?
I have a question.
Yeah.
Don't you feel bad because you were a card counter? Now you jacked all the card counters by telling how they did it.
No. The people got in trouble is not about card counting. No, they were literally stealing money.
The
The
employees.
dealers were giving them extra money.
You said that you work for the casinos also in
Oh, I did that. I don't feel bad about that.
Hello, you were a cheater. How can you now turn on your crew?
No, card counting's not
crew,
cheating.
Industry
Card counting's not cheating.
not officially, but I mean,
card counting is
happens.
Card counting is thinking, not cheating. Big difference.
But they're not exactly welcome back once it's found that they're
No. I was not welcome back. No, it was worse. They said they were gonna kill me. But
And
now it's not mafia driven. So what I did is I helped it move from the mafia to the corporations, which I think is a good thing.
Oh,
So it's not mafia driven. The casinos used to be mafia driven. Now they're corporation driven, which means the corporations have to do more than kill people. You see? So I help the corporations be able to have a corporation. Nothing wrong with that.
I
Okay?
agree with Michael. You're beating the game.
Yeah, nothing wrong with being in the game.
No, it's win-win, honestly, in every area.
But anyway, let's get to this. And I'm going to try this, but I'm not sure if this is going to work because I've never tried this before. But we'll see. Okay, so here's another one. This is life insurance. Okay, so you have been offered a life and dismemberment insurance policy. Okay, that costs $1,000 a year. The policy pays the heirs $100,000 in the event of death, because if you die, you don't get any money or death, right? On the other hand, if there's dismemberment, do you guys all know what dismemberment means? It's not a math word, it's an English word. Yeah, loss of a limb or something like that. Could be an organ, could be an ear, could be an eye. Basically, loss of some big part of your body. Okay, and you get $50,000 if that happens. By the way, with this kind of insurance, you hope you lose your $1,000. By the way, just note. Okay, the actuaries have determined that you have a 0.3% chance of dying this year and a 0.5% chance of dismemberment this year. Find the expected value and interpret it, by the way. Okay, so what I'm going to do, and we'll see if this works because I haven't tried it before, is I want you to spend about 5 minutes working together in groups. Okay, and let's see, I might have to put this in the chat box because I don't know if I can share my desktop with this. And let's try it. Let's go 3 different groups. Okay, and I want you to work in groups and talk about it. Okay, so you're all, so it says you're invited to join breakout rooms. I think you might have to click join. I'm not sure about that, but that's my guess. Yeah, I see people doing it. And then talk to each other in your group and see if you can come up with the answer. And hopefully all 3 of your groups came with the same answer. And I've never used this before, but we'll see. So all but 2 people have joined a group. So hopefully the 2 of you can join also. And I'm going to give you 5 minutes, talk it over. You're going to need that spreadsheet program. And let me put that in the chat box also. Not even sure if you can hear me when you're in your groups, but that's a messy URL. Starts with HTTPS. And I'm here for questions if anyone has them. I think I can hear you all, but I'm not even sure about that. But talk to each other, or at least in chat box. And we'll go until 35 after. Okay, looks like we're all coming back. Okay, so the first thing is, what did you get? What was your expected value? Okay. Do the other groups agree? Good, good. Negative 450. Okay, so
Oh,
what do you think? Is this a good buy?
Well, if you die or become dismembered, it is.
Huh?
If you die or become dismembered, it is.
Right, but you don't know if you're going to die. Right now, you don't know if you're going to die, right?
Right.
I hope you don't know you're going to die.
Stress and strain out of your movement.
Okay, so is this a good buy?
Or a 10-bedroom mansion, you can feel safe and confident.
What do you think? So here's the deal, okay? You look at negative 450. First thing is, you can't just say if you tried this many times, but what you can do is you can actually flip the coin, and you can think of it in the side of the insurance company. So is this a good business?
More and more people paying premiums than you are paying out payments.
Yeah. So what this says is that you're expected, so for the business, the expected profit per customer is $450. Does not mean, in fact, no customer will ever lose $450. That'll never happen. So expected value is not a number that happens. It's an average. Makes sense? So it's an average. So I'm gonna mute. There we go. Yeah. So if you want to talk, but I want to mute if you have background stuff. So the first thing is that the expected value says what? Let's see if someone can tell me what you talked about in terms of what this expected value means. You work in groups, you're supposed to talk about it. You get the number, but the meaning is important too, and you're going to be asked that on quizzes and tests. What 4 words? Okay. What 4 words? You can unmute yourself and say it. Okay, most likely, average, close to, okay, and many, don't forget the many. Okay, so on the business side, we use those 4 words. Is that if there are many customers that purchase the insurance, then it is likely that the average profit per customer for the insurance company will be close to $450. Any questions on that? Okay. All right. But now you want to think about the purchase. Now, this is where the standard deviation comes in. Was the standard deviation high or low?
High.
Yeah, it's very high, right? So here's the deal. What that says is that it's a big deal that sometimes it's gonna make a big difference having that insurance. So you have to decide whether that's real important to you. So for example, if you have small children, life insurance is probably really important. Okay. On the other hand, my daughter's 25, she's fine. I paid for her college already, that's already done. I probably don't need life insurance. Does that make sense? Okay, or if you're a student and you don't have a family, like kids that you're taking care of, you definitely don't need life insurance because no one's going to get damaged because of your death financially. It'll be really sad. I know a lot of people will cry and all that, but no one will be financially destroyed. Okay, any questions on that? Okay, if the results on the calculator was NAN, my best guess is you used a comma when you typed in the bigger number. Is that possible, Michelle?
I didn't type them in.
Oh, well, whoever did. Yeah, most likely is a comma. Numbers can't have commas in them. Yeah, so that's the most likely reason for an NAN. Could be had some other letter in there for some reason. But you have to put a number in, nothing other than 0 through 9.
You know, something else that we had that maybe we'll know then for next time we have a breakout session is we wanted you to come and help us, but in the chat, we were only able to chat with each other within our own breakout group.
Yeah, there's a way, there's a button, and a few of you hit it, that calls me.
Okay.
And then I come into your room, and I did that for some of you guys. So
Yeah,
that might have been the reason.
You can invite the host to your breakout session. I think it's
Yeah.
on the bottom right when you're in a breakout session. Just click on the
right.
3 dots on the bottom right and it'll give you some options.
Yeah. Okay. Any questions on this before we go on to the next topic? Okay, let me go back to share. Okay, so the next topic. First thing, let me type a few things. We're going to look at a binomial distribution. So that means the survey, Discrete, oops. That means the survey question is yes or no. And it could be like yes or no. It could be, you know, won the lottery or didn't win the lottery. Okay, that's not quite yes or no, but it's basically yes or no. Okay, had the child, or, you know, got pregnant or didn't get pregnant. Okay, things that are yes no question. And there's lots of yes no questions that happen in the real world. Okay, so if you have a survey questions yes or no, and you want to find the probability of a certain number or range of numbers of yeses, we call this a binomial distribution. And there's some mathematics which I'm not going to do because you don't need to hear it. If you want to come to my office hour, I'd be happy to show you. And then you bring some Kleenex because it might make you cry. But there's some tough math in this stuff, lots of factorials and messy stuff. We're not going to do that. What we're going to do is we're going to learn how to do this with a computer. So I'm going to give you an example. This is best done by example. So here's the example. Okay, and the example is the following. 20% of all community college students transfer to a 4-year institution. Suppose that 50 community college students are selected at random. Okay, find the probability that, in part A, we're just going to do part A first, exactly 10 of them transfer to a 4-year institution. So first thing, why is this binomial? Any thoughts?
Well, it's
What's
a
a
specific number.
What's a survey question? Yeah, the survey question is, did you transfer to a 4-year university? And the answer is yes or no. You can't kind of transfer. Does that make sense? So it's a yes, no question. And we have a sample size of 50. And we want to find out a number that said yes. And in particular, we want to find out the number that said exactly 10, if the number is exactly 10. So first thing, it's binomial. Okay. And sometimes we'll call this a binom PDF, but I'm not going to get that. That's more with a calculator. Computers don't need that. So it's a binomial. And we have some information. First thing is, what's the probability that somebody says yes to the survey question?
20%.
20%, but you need to write that as say as a decimal, not as a percent.
0.20.
0.2, yeah. So that's the first thing, is P is equal to 0.2. Any questions on that? Okay, what is N? Have we seen the letter N before? Yeah, N equals 50. What is the range? This is a little weird looking. What are the range of values for part A? Any thoughts? What's the lowest number to say yes to part A?
0.
Okay,
0.
0 is not exactly 10. Yeah, 10. 10 is the lowest number to say yes to part A. What's the highest number to say yes to part A?
10.
10. So the range, it looks a little weird, is 10 to 10. And when you have discrete distributions, this actually is very meaningful. Okay, when you have continuous distributions, it turns out this is not very meaningful. So the range is 10 to 10. Okay, so now what I'm going to do is I'm going to show you, and I think what I'm going to do is I'm going to show you what it's going to look like for you on the quiz, so that you know how to find it. So on the quiz, this is not what it's going to be. It's going to be this. I have to get there. And it'll be there for you. Okay, by the way, these are all the programs I wrote. And I wrote one today.
In your spare time.
Yeah, that was a 3 in the morning to 6 in the morning.
I was watching your videos then.
Oh, good, good. Okay, that one. Okay, so this is what it's going to look like for you when you take the quiz. It's going to look like this. You're going to scroll, and you have to find the right calculator. You'll notice that there are 24 calculators I've created. And which one is the right one?
Number 6.
Yeah, number 6, binomial probability. Right now, that's not hard because we haven't learned all the others. I will let you know in the final exam. We'll know all these, and you're going to have to know which one to use. Does that make sense? So if you click number 6, which you're going to have to do on the quiz, by the way. Okay, and by the way, if I go back just a second, what we've been doing is number 5. That's expected value and standard deviation. But we're going to click number 6. Ah, shoot. There we go. I tried to make it easy. What's the lowest number that makes this true? What number should I put in? We've already talked about it.
10.
10. What's the highest number?
10.
How about trials?
Is that the 50?
That was a 50. There were 50 trials, is what we say. And what's P? P is 0.2. Okay, and remember that came from the question. P is 0.2, N is 50, range was 10 to 10. Then we hit calculate. And the answer is 0.1398. Any questions on part A? Okay, so now we're going to get into some of the things that some people have trouble with. At most, 12 of them transfer to a 4-year institution. So notice that the N is the same, P is the same, P and N are the same. What's the range? See if you can tell me what the range is.
1 to 12.
Close.
0 to 12?
0 to 12. Right? Because if nobody transferred, that's still at most 12, right? Does it make total sense? So that's usually the hard part, is kind of reading this like at most and understanding what that means. And that, in this case, it means 0 to 12, and most 12 is 0 to 12. So then I just go over to the calculator again. And my low now is 0. My high is 12. And there it is. And it's about 8.8139, or about 81%. Any questions on part B? Okay, let's look at part C. At least 9 of them transfer to a 4-year institution. Let's see if you can, do the whole answer. See if you can, let's see if you can tell me the range. And I'm going to put the link in so that you can go and do it, because it helps to be able to do it. So there's a link. And let me put the question back. We're at least 9. And what a lot of people have trouble is the range. So I'll give you a minute or so and see if you can do this. And when you've got it, you can put it in the chat box, or you can say it. The range you should be able to do in, a second or two if you understand it. And if you don't, then it won't ever happen until I tell you. And then hopefully you'll eventually figure out how to read the words. Okay, so we got one person thing. So let's see if we have a second, or someone with a different number. We'll find out. Good. You're all getting the same thing. So the range is going to be 9, 50. Okay. The way I like to remember at least is that, in case you have trouble with the words at least, is that hopefully you all know that you have to be at least 21 to enter the bar. Do you all agree? Actually, I shouldn't even say that. At this point, you can't enter a bar, but you have to be at least 21 to buy alcohol. That you're allowed to do. No one's allowed to enter bars anymore. But you can you go to the store and buy alcohol. That's actually an essential. You have to be at least 21. And hopefully you know that starts at 21. It's 21 and up. Is that clear? So I think it's good to have something that you remember. And I think everyone knows what it means to be at least 21 to enter, to buy alcohol. Or at least 18 to vote is another one. Okay. And 6927, should I try it? 950. And 0.6927. Okay, how about less than 14 of them transfer for your institution? See if you can do that one. And I always like to write down the range to start. all of these have the same N and same P because it's the same first paragraph. Okay, so what's less than 14? What to what? What's the range? Yes, you gotta be very careful. It's not 0 to 14, it's 0 to 13. Because 14 is not less than 14. So it's really important to kind of read, because a lot of people make that mistake. Okay, 0 to 13, and if you pop that in, I can't do that in my head, by the way. And 0.8894. And then finally, more than 11. So yeah, the first is a range is going to be 12 to 50. Okay, and the answer is so we go 12, we go 50, calculate, and 2893. That's the wrong one. That one. Any questions on this idea? Any questions? Okay, now let me talk about one more thing, and then we'll maybe one more example that's somewhat a real life example. Okay, so here's another example. 21.2% of high school seniors have used marijuana. Okay, this one I actually found somewhere, okay, a few years ago. That one's a really hard one to actually get the actual numbers. Why is this one so hard to get the actual numbers?
Because people aren't going to truthfully answer the question every time you ask.
Exactly, especially high school kids. Okay, so I don't know if I trust this, even though I found it a reliable source. I don't know if there's any source that's truly reliable, but we'll just call it 21.2%. A study of 200 high school students in states that have legalized marijuana for recreational use found that 49 of them used marijuana. So what we want to do is we want to say, is this statistically significant? Those are some words we haven't had yet, and it turns out they're probably the most important 2 words in the whole class, and not the day, but the entire course. We're using these words a lot, so this is a little prelim of something we're going to be doing. So what we want to do is we want to find the probability that at least 49 out of 200 have tried it, given that it's a 21.2%. Any questions on the question? All right, so what is N? What's N here? And by the way, you either tried it or you didn't. You can't kind of have tried marijuana. What's N? Still waiting for N. I'm gonna do one thing at a time. N is 200. What is P? 0.212. Okay. And what is the range? Yeah, 49 to 200. Because that's what at least means. And then we can just pop it in the calculator. Let me write this down because I'm going to be losing it. So P equals 0.212. The range is 49 to 200. Go to the calculator. So our low is 49. Our up is 200, our upper bound. Number of trials, our up is also 200. And our P, probability of saying yes, is 0.212. And we can calculate. Up trials. Let me refresh. Try this one more time. So low was 49. The upper was 200. Number of trials was also 200. And it was 0.212. NaN.
Look at that.
Uh-oh. Huh? Y'all getting NaN? I wonder if the number's too big. I gotta check this. Okay, I'll have to check this. There might be a bug in this. So let me see. Try round. That shouldn't matter though. No, that won't make a difference. Let's do the following. I have a feeling that it couldn't handle 200 factorial. All right, so we're gonna divide by 10. I gotta see, I think it has to do with the numbers got too big. That's why the NaN happened. Is there's a factorial in there and 200 factorial is too big. I don't think there's a bug in the programming, there's a bug in the whole system that I didn't write. So about 0.423. Any questions on that? Okay, so now that's actually a pretty high percent, and that we would say it's not statistically significant. Okay, would your answer change if you found out later that some students lied and instead of 49, it was 54?
Yeah.
So I'm going to change this. I'm going to change this 5 to a 6.
That
And-
didn't work.
Huh?
It's still 5.
Oh. There we go. And you get 0.2367. Okay. It turns out statistically significant, you need to be less than 5% for standard. And that's just, we'll get that later. Any questions on this? Okay, let me do one more really important one. And that is there climate change? What do y'all think, by the way? And in particular, is there global warming? Okay, y'all think yes, right? Now, I mean, do you know because it's like been warm lately? Is that why? How do you know? Okay, and the idea is you probably know because you trust the scientists. Okay, that's my guess. But what I'm hoping is you're going to be able to do better than trust scientists. You're going to be able to read the science and understand it. Okay. Okay. So let's take a look. Okay. By the way, the Earth moves away from the sun 6 feet every year. That still is not about warming or not. It might be, but we don't even know if that's going to matter that much because the sun's also getting hotter. Just want you to know that. There's all kinds of things going on. Okay. But let's look at this. How many of the last 10 years were in the top 100 years? That's right. How many of the last 10 years were in the top 10 warmest years? Hopefully it'll say. Okay, so here we go. 10 hottest years on record. And let's take a look. And by the way, we don't know 2020 yet. Here's the 10 hottest years on record. So notice that in the last 10 years, so that would be 2010 through 2019, 6 of them were in the top 10. Okay. Any questions on that? Okay, now the record has happened since, I don't know if this, since 1880. Okay, and by the way, from 1880 to 2019, there were 140 years. And
When you're counting that, you count that. Never mind. I answered my own question as I spoke.
okay, good, good. Okay, so 6 of the last 10 were in the top 10. Does that make sense? So notice that this is a binomial distribution because you're either in the top 10 or you're not in the top 10. Is that clear? So let me go back and now we can start computing. And now we can start saying, you know, is this unusual or is this a usual thing anyway? You know, is it not, would it be likely to just randomly get 6 out of the top 10? 6 out of the last 10 to be in the top 10. So what is P? What's the probability that any randomly selected year will be in the top 10 hottest years?
We said 140 years?
140 years. The idea is it's 10 out of 140. That's a probability you can be in the top 10. There's 10 that you can, there's 10 that are in the top 10 out of 140 possible. Okay, which by the way is 1 over 14. We're going to need a decimal. Okay, 0.0714. I like that. I was about to do that. And that's the probability of being in the top 10. What was N? This one's supposed to be easier. What was N? Yeah, 140. And we want to say, what's the probability of having at least 6 in the top 10? So what is the range?
0.
At least 6.
0.
0 is not at least 6.
6 to 140.
6 to, well, you can't have 140 of the last 10 years being in the top 10.
Okay.
6 to 10. Okay, and actually N is not, sorry, N's not 140, N is 10. I made a mistake on that. Because we're looking at 10 different years, our last 10 years. And the range is 6 to 10. The probability of being in the top 10 is 0.0714. Any questions on that? So now what we can do is we can compute. And hopefully it doesn't give us this problem again. I don't think it will. So we're looking at the low is 6. The upper was 10. The number of trials was also 10. And our P was 0.0714. And shall I hit calculate? Oh, I got 2 points. That was my typo. And what does it give you? 0. And by the way, this is to 4 decimal places. So that means rounded to the nearest 4 decimal places, we get 0. So it's less than 1 in 10,000 chances. So do you think that this is strong evidence to say that we're in a period of global warming? What do you think? Okay, the answer is yes. And the reason is that the definition of strong evidence is less than 1% chance. This is less than 1/100% chance. Does that make sense? Okay, so what this probably means is that our years are not random. Something is going on. Okay, this doesn't tell you what's going on, but this tells you that it's very likely that something is going on, that this didn't just randomly happen to have these 6 warm years. Does that make sense? Okay, then you have to find out what's going on, and that's where science comes in. And I'm not going to, give a class on, climate and all that stuff, but that's where science comes in. You look at the different possibilities, and you see which ones have happened, and then say, if only one of the possibilities has happened and everything else didn't happen, then that was the one. Okay, any questions on that? Okay, and by the way, the main thing that's happened is carbon dioxide. And that's a long story that's not statistics, that's chemistry, which I'm not going to get into. I was a chem minor, by the way, and I took a course on this. Okay, a long time ago at UC San Diego. Any questions at all on either the expected value or a binomial distribution? Okay. This is pretty much all I needed to say. We still officially have 7 minutes and then have office hours. But I'll be happy to answer any questions if you have any. Any questions at all? Any questions? Just to let you know, I think I don't want to show you the whole quiz. Let's see how much I can show. I'm gonna do a stop share. I want to show you what it's going to look like. I curve the grade when I grade I only curve a little bit, but not a lot of curving. I don't do a standard curve or anything like that. Okay, because I've been teaching long enough, I give the same questions not the same questions, same level of difficulty every year, is what I should say. The questions change, okay, but the level of difficulty doesn't change. Let me do something in a moment. Hopefully I can do it without you seeing too much. Yeah, that's about right. Okay, just a second.
Do you see the question about notes on the quiz?
Just a minute. I take it, yeah, for the quiz, we're not going to do notes. But, I mean, there's only 2 things. There's binomial and there is expected value, and it's not like there's a formula. Okay, so just a note is that this is kind of the bottom of one of the problems in the quiz, and you're going to see this embedded. It's going to be kind of small, and you're going to have to scroll it down so that you can get to the calculator, and then you're going to be able to enter your values in. Does that make sense? And then you're going to scroll down more, and you're going to hit calculate. Maybe I should put some values in so you can see what it looks like. So this will be embedded in your quiz. How about 0.6, 0.4? Oh, sorry, no. How about 5, 4? How about, I don't know, 11? and just making up some numbers, 0.6. By the way, you're not gonna be the right answer for the quiz, so don't just like say, oh, it's 0.6. I'm just making up some numbers. And then you hit calculate, and it'll give you the expected value and standard deviation. So your quiz will have this calculator in the problem itself to make life easier for you. Okay, the exam, on the other hand, actually it may not. I think I changed it, and I think it hasn't upgraded. You may have to click the online expected value and standard deviation calculator, and then it'll show this. The quiz should not have NaN because I tested it and it worked. Just let you know. I didn't test all the other things I tried.
Okay, and then for the exam, will we have notes available?
Sorry, I wasn't able to hear.
For the exam, will we be able to have notes?
For the exam, you get a little note card that you get to write.
Online or physical note card? What do you mean?
I think it's gonna have to be physical. So
Okay,
you're gonna show it to this camera.
sure.
It's gonna work. Any other questions? And I think what I'm gonna do is I'm gonna drop the recording. We're kind of in office hours now.